So in this video, we're going to learn how to convert from one kind of rate to any other kind of rate. And we've picked up quite a few rates at this stage, which I'll talk about. So I'll step off, please pause the video, copy these notes down in your notebook, and then press play and I'll talk through. Okay, so we've got annual effective rates, annual effective discount rates, monthly effective interest rates, monthly effective discount rates, and then the nominals for those two as well, which we don't actually use in computations, right? So we'd like to be able to flip from any one type of interest rate to the equivalent in any other type of interest rate setting, right? So let's just recall some terminology. I was our annual effective interest rate, D was our annual effective discount rate, T was the number of years. We set years as our default unit of time, 1 year. I superscript M over M was the monthly effective interest rate. Without the denominator of M, that would have been the nominal interest rate compounded monthly. D superscript M divided by M is the monthly effective discount rate. And we had a bunch of accumulated value formulas for each of these 4 types of effective rates. So the accumulated value at time T was the present value times 1 plus the annual effective interest rate to the Tth power. Or if you're using monthly effective, it was the accumulated value was the present value times 1 plus the monthly effective interest rate to the M times T power. Or if you're doing annual effective discount, we took the present value and divided it by 1 minus D to the T to push the money forward. And that might not seem completely familiar, but the formula we actually came up with was that the present value was equal to the accumulated value times 1 minus D to the T. And if I want to solve for the accumulated value, I'll simply divide the 1 minus D to the T underneath the present value, as shown there and there. And then exactly in the same fashion, if I use the effective monthly discount rate, there's the accumulated value formula for it. So all of these formulas, or all these expressions, tell me accumulated values after 2 years. So to convert from one to the other, I'm going to make my life slightly simpler. I'm going to say the present value is going to be $1. And I'm going to let the time that I'm interested in be 1 year, just to make things start to cancel out nicely. So if I do that, 1 year and $1 for present value, that last line I had down on the left here gets converted into this. All the PV zeros are 1, all the T's are 1. And then a lot of those 1s don't need to be there, right? So let me just tidy it up and I get to here. So 1 plus I is equal to 1 plus IM over M to the nth, which is equal to 1 over 1 minus D, which is equal to 1 over quantity, 1 minus D superscript M over M to the nth, okay? And that is the formula we're going to use to convert from one to the other. Now, would I memorize that? No. I would just remember my accumulated value formulas and redo this, okay? So let's do an example. Determine the nominal discount rate compounded quarterly that's equivalent to a nominal interest rate compounded monthly of 10%, all right? So I've been told the nominal interest rate compounded monthly, I superscript 12, is 10%, 0.1, and I'd like to know the nominal discount rate compounded quarterly, so D superscript 4, okay? So what I'm going to do from the box up above is I'm going to grab that piece because it involves monthly interest, and this piece because it involves monthly discount, and that's what my 2 rates are speaking to. So there's my monthly interest rate, there's my quarterly discount. So I grab those 2 pieces. In the interest rate one, M was played by 12 monthly, and in the discount one, M was played by 4 quarterly, okay? I will plug in the nominal rate I superscript 12 to be 10%. And that's the only change I've made from the previous line. And now you'll see that there's only one thing I do not know in this entire expression, and that's the object of my desire, D superscript 4, the nominal discount rate compounded quarterly. Okay, so I'm just going to go through algebra here and crank it out. Please note from the previous step down to this one, instead of dividing, I changed the exponent to a negative sign. All right. So using the calculator, 1 plus 0.1 divided by 12, quantity of 12 cranked out to 1.1047, and I think I kept 8 digits on my calculator. To get rid of the negative fourth power, I'm going to raise both sides to the negative 1/4 power. So that 1.1047 to the negative 1/4 power cranked out to be 0.9754, . I added the D4 over 4 to the other side, subtracted the 0.9754, and I got my quarterly effective discount rate to be 0.02459, multiplied the 4 to the other side and got my nominal discount rate convertible or compounded quarterly or convertible quarterly to be 0.09836, or in other words, 9.836%. So if you offer me 10% nominal interest convertible monthly or 9.836% nominal discount converted quarterly, I don't care which one you give me because they're both equivalent. They will do the exact same thing to my money. And again, please don't feel you have to memorize this. As long as you can create the accumulated value with each type of interest, you can set those two accumulated values equal to each other, cancel the PV zeros, set t equal to 1, and you'll be right back to here, right? So don't try and memorize all these formulas. Think through them and memorize the minimal number that you need.